Hey everyone! Welcome back to my channel. Today we're going to be learning about how to solve a systems of linear equations through elimination. Let's get started. So let's say we have a problem to solve here, something like 2x plus y is equal to 5, and the second one is minus 3x minus y is equal to minus 7. So if we had a systems of linear equations like this and we wanted to solve it through elimination, how would we go about doing that? Well, what we would do is we would kind of add the two equations together and try to get rid of one of the variables, so we are able to solve for the other one. So that sounds kind of complicated right now, but here's how this would kind of go. In this one, as you can see, we have 2x plus y is equal to 5, and below it we have minus 3x minus y is equal to minus 7. So what we could do here is we could just kind of add this entire equation together to get just one equation at the bottom. So we combine these two x terms here, these two y terms here, and these two constant terms here on the other end of the equal sign. So we would do 2x minus 3x would leave us with negative x, and then y minus y would cancel each other out. So you see how we just got rid of one of the variables? So that's just going to leave us with minus x is equal to 5 minus 7 minus 2. So that leaves us with the equation minus x is equal to minus 2. And to solve for x, we divide both sides by negative 1. And we end up getting that x is equal to 2. So our solution for the x coordinate of the solution is going to be 2. Now to solve for y, what we're going to want to do is plug in the x value of 2 into either of the equations, and then solve for y. So one of the equations that we had was 2x plus y is equal to 5. And now I'm going to plug in the 2 for the x so that I can solve for y. So over here we're going to have 2 times x, which is 2, plus y is equal to 5. So 2 times 2 is equal to 4, plus y is going to be equal to 5. And we're going to subtract both sides by 4. And that's going to leave us with y is equal to 1. So our y coordinate for the solution is going to be 1. And together, this coordinate point makes up the solution to our systems of equation. Let's try solving another one. Let's say we have this systems of equation and we want to solve it using elimination. For this one, as you can see, we want to follow the exact same method that we did before, which is adding them together. But if you look here, we can't really add these two together. What's going to have to happen is that both equations are going to have to be in standard form, meaning something like ax plus by is equal to c. So something times x plus something times y equal to like a constant term, like a plain number. So as you can see, our first equation is in standard form, but our second equation isn't. But luckily, all we have to do to solve that is subtract by 5y on both sides to leave us with 8x minus 5y is equal to 20. That's now in standard form. So I'm just going to rewrite this over here. So this is now our systems of equation. Now we're going to add these two together. So 8x plus 8x is equal to 16x. And then 5y minus 5y cancels each other out. And that leaves us with 16x is equal to 220 plus 20, which is 240. So 16x is equal to 240. And so we're going to divide by 16 on both sides. And we're going to get x is equal to 15. And so that's going to be our x-coordinate for the solution. Now, again, remember what we have to do to get the y-coordinate is just plug in 15 for the x in either of the equations and just solve for y. So I'm going to choose the first equation to plug the x value into. So that was 8x plus 5y is equal to 220. And now we're just going to solve for this. So we have 8 times x, which is 15, plus 5y is equal to 220. So 8 times 15 is 120, plus 5y is equal to 220. So we're going to subtract 120 from both sides, and we're going to have 5y is equal to 100. And then divide both sides by 5 to get y alone, and we're going to have y is equal to 20. So that's going to be our y-coordinate. So 15, 20 is our final answer to our systems of equations. Let's move on to the next one. So here is our next one. Over here we can see that both of these are in standard form, so we should be good to add these up. So if we add these up, we're going to get 9x minus y is equal to 25. Now, as you can see, this time it didn't get rid of a variable, meaning we can't solve for either x nor y. Why did this happen? Well, in the previous equations, we had something like 5y, and then on the bottom we had something like minus 5y. Or we could have had something like positive 5y and positive 5y, and instead of adding, we could have subtracted. But in this case, neither the x coefficients nor the y coefficients match up in both equations. What we're going to have to do in this situation is actually multiply one of the equations by a constant to be able to subtract or add both equations together and leave just one variable. So looking at this, you kind of want to find which one would be easier to multiply. Obviously, I could multiply the top equation by 4 and the bottom equation by 5 to get plus 20 on the 20y on the top and minus 20y on the bottom. But I think that would take too long. What we could do instead is just multiply the top equation by 2 on both sides and get 6 for both of the x coefficients. So I'm going to do this out to the side. 2 times 3x is 6x, and then 2 times 5y is 10y. So we have 6x plus 10y on the left side, and negative 1 times 2 is equal to negative 2. So since we multiplied the equation by 2, now we have 6x plus 10y is equal to minus 2 as our systems of equation. From here, we can solve. So in this case, if we add both of them, then we're still going to end up with 2 coefficients, or 2 variables, and that's not what we want. Instead, what we can do is subtract. So we're going to have 6x minus 6x cancels both out, and then minus 4y minus 10y leaves us with negative 14y. And 26 minus negative 2 is the same thing as 26 plus 2, which is 28. And so to get just y, we're going to divide by negative 14 on both sides, and that's going to leave us with y is equal to negative 2. So that's going to be the y-coordinate of our solution. Now what we do is just plug in -2 for y into either of the equations. I'm going to choose the first one. So we're going to have 6x minus 4 times -2, which went in place for the y, is going to be equal to 26. So we're going to solve for this. We're going to have 6x minus 4 times -8 is plus 8 is equal to 26. I'm going to subtract 8 from both sides. We're going to have 6x is equal to 26 minus 8, which is 18. And now we're going to divide by 6 on both sides to get our x, and we're going to have x is equal to 3. So that's going to be the x-coordinate of our solution. So 3, -2 is our solution to this one. Let's try solving one last one. So here's our last system of equation. Minus 18x plus 6y is equal to 24, and 3x minus y is equal to -2. So looking at this one, for the x and the y's in both equations, neither of them have similar coefficients. So what we're going to do again is multiply. So what I'm going to do is multiply by 6 for the bottom equation, so I can get minus 6y for this term. So we're going to have 6 times 3x minus y and 6 times 2. So 6 times 3x is 18x, and 6 times -y is minus 6y. And -2 times 6 is equal to -12. So this was our second equation. And now our first equation stays the same, so I'm just going to write that underneath. So now that we have both of our new equations, we can just get rid of everything on the top. So we're left with this. Now for this, what we're going to do is add them together. So for here, 18x plus -18x cancels each other out. Then -6y plus 6y also cancels each other out. And so that on the left side, we just have 0. So we have 0 is equal to -12 plus 24 is 12. So here is a special case. Right here, we're left with 0 is equal to 12. Now, we all know that that's not true. 0 is not equal to 12. 0 is equal to 0 and 12 is equal to 12. So when something like this happens, where both of the x and y terms get canceled out, and we're just left with two constants, it can go either one of two ways. If the equation, or well, it's not really an equation, but if whatever is left is true, then that means our solution is going to be A, R, N, or all real numbers. So like, for example, if we had 12 is equal to 12, that's true, right? So our solution would be all real numbers. So every number that you could think of would be a solution. But if the equation we get is false, so like this one is false, right? If the equation we get is false, that means that we have NRS, or no real solutions. So like if we had something like 0 is equal to 12. So since 0 equal to 12 is false, we're going to have no real solutions. Instead of writing out no real solutions, you can also just do this symbol, which also stands for no real solution. That there is no number that could satisfy the systems of equations. So our answer for this one would just be no real solutions. So that's it for today, guys. I hope everything was clear and you understood everything I was saying. If you have any questions, please drop them in the comment section below. If you like my videos, please like and subscribe. Also, be sure to follow me on Facebook and on Instagram from the description below. Thank you so much for watching. See you next time. Bye!